Hello friends, welcome to Learner's Planet. Friends, this is our first session for trigonometric functions. The basics of trigonometric functions, how many types of trigonometric functions are there that we have already discussed in our grade 9 and 10, right? Precisely, there are 6 types of trigonometric functions: sine theta, sine, cos, tan, cosec, sec and cot, right? Uh, Here in this year, we'll be learning more about trigonometric functions. Till grade 10, you might have learned about the trigonometric functions in the range 0 to 90 degree, right? In this year, we'll be taking trigonometric functions of any degree, right? You should be able to you'll be able to calculate sine 360 degree also, sine 900 degree also, right? So precisely this is our first session, so we are just going to discuss the basics of trigonometric functions for this grade. So let's begin the session. Now first of all, let's discuss what exactly trigonometry is. Trigonometry means the science of measuring triangles, right? Or it is a branch of mathematics which deals with measurement of sides and angles of a triangle, right? Till last year, we used to connect trigonometry with a right angle triangle, right? We used the three relations: sine square theta plus cos square theta is equal to 1 plus cot square theta is equal to cosec square theta, and 1 plus tan square theta is equal to sec square theta, right? We discussed the three relations last year, right? All these relations were based on or we can say we used to use for right angle triangles. Okay. This year will expand our knowledge. Okay. Next is, what is an angle? A figure obtained by rotating a given ray about its endpoint, right? This is the initial side, this is the terminal side, this is angle, right? This is known to be vertex, initial side and terminal side, right? So that's angle, that's theta. Measure of an angle is the amount of rotation from the initial side of the terminal side. See, you don't have to mug up the definitions. It's just for your reference, right? Precisely all these things you know, because angles you might be learning from your grade 6 or 7, right? So you don't have to mug up the things. You just listen to me and just have some idea about it, right? Now the angle is considered positive if the initial side rotates in anti-clockwise direction, and negative if it rotates in clockwise direction, right? You can see this direction of rotation, right? Here it is going in this direction, so this is positive, and here it is rotating in this direction, right? So this is negative, right? This is anti-clockwise and this is clockwise, right? So the angle is considered positive if the initial side rotates in anti-clockwise. You can see this movement is anti-clockwise, right? So this is positive angle, and when the movement is negative or movement is in clockwise direction, then the angle is negative. Okay. And if initial side describes 1/4 of a circle, then we say the measure of the angle formed is a right angle, right? Precisely, I just show you one right angle. You already know this. You can see YOX, right? So this is actually 1/4 of the circle, so YOX is 90 degree. Okay, now next up that we have to learn is the quadrants. Last year you might have learned the quadrants in your coordinate geometry sessions, right? In your coordinate geometry. So this year we'll be using the quadrants in even trigonometric. So just listen to me carefully. You must be knowing that this line x dash and y dash, this is x axis, this is y axis, right? Horizontal, vertical. So horizontal axis is x axis, vertical axis is y axis, right? Now there are 4 quadrants: first quadrant, second quadrant, third quadrant and fourth quadrant. In first quadrant, x and y, both of them are positive. In second quadrant, y is negative, but y is positive but x is negative, right? So this is the negative side of x. In the third quadrant, X and Y, both of them are negative, and in fourth quadrant Y is negative but X is positive, right? So these are uh, the four quadrants. Okay, now friends, let's discuss system of measurement of angles, right? First of all, we have hexadecimal or English system. In this system, a right angle is divided into 90 equal parts called degree, right? That we already know. A right angle is 90 degree. This is a sign of degree, right? So 90 equal parts are there, small parts are there. Each part is 1 degree, right? So 90 part is 90 degree. Precisely 1 degree is equal to 60 minutes. Or we can say each degree is divided into 60 equal parts. We call them minutes, right? And each minute is further divided into 60 equal parts. We call them seconds, right? So 1 degree is equal to 60 minutes. This is the sign of minute, right? And 1 minute is equal to 60 seconds, right? Next is French system. In this system, a right angle is divided into 100 equal parts. We call them grades, each grade into 100 minutes and each minute into 100 seconds, right? You just have to, you should be knowing this, otherwise you don't have to mark up this because it is generally not at all used. We generally use this system, English system, right? So this is what the conversion. Then the next is circular system that we are going to study this year, right? In this system, unit of measurement is radian. 1 radian, or we just denote radian like this. A radian is a measure of an angle subtended at the center of a circle by an arc of length equal to the radius of the circle, right? So number of radians in an angle subtended by an arc of a circle at the center is equal to arc by radius, right? So theta is equal to length of the arc by radius of the circle. Okay, so theta is equal to L by R. Theta in radius is equal to L by R, where L is length of the arc and R is the radius of the circle, right? If I draw a circle over here, so here this is theta, this is the length of the arc and this is radius, right? So theta is equal to length of the arc by radius of the circle. Okay, now this is really important. Pi radian is equal to 180 degree, right? Radian we denote as this. Pi radian is equal to 180 degree, right? Generally we write it as pi only, though you know the value of pi, that is 3.1416, that is 22 by 7. So it's actually cannot be expressed exactly either by a whole number or by a fraction. It is basically an irrational number, right? But exact value of pi is not known because it cannot be expressed in p by q form, right? Precisely, or we can say approximate value of pi is 22 by 7 or around 3.1416, right? Correct to 4 decimal places. Now what is the relationship between three systems of measurement of angle? See, this is really important. Pi radians is equal to 180 degree. Okay, or what is the relation? This is the relation, but you must be knowing this and this. Okay, that's important for us. Now what is the area of sector of a circle? See, you, last year in your grade 10 you might have studied about the area of a sector of the circle, right? Precisely this is sector OAB, right? Over here what is the area? That is I can say theta by 360 into pi r square, right? Pi r square is the area of the circle. Now whatever is this angle, that is theta divided by 360 part of pi r square, right? So that is the area of the sector. Now pi radian is equal to 180 degrees, so it is precisely theta by 2 r square. Okay, or we can say r square theta by 2 half r square theta, right? Pi is 180 degree. Okay, so this relationship you must be knowing. Now we already know trigonometric function sin square theta plus cos square theta is 1 plus tan square theta is sec square theta, and 1 plus cot square theta is cosec square theta. That we have already discussed in our grade 9 and 10. So I don't have to repeat this. All how do we derive them, everything you must be knowing, right? So just move on. Now the very important thing, very important, signs of trigonometric ratio in quadrants, right? This is first quadrant, second quadrant, third quadrant, fourth quadrant, right? All ratio will be positive over here. Sine and cosec will be positive, rest negative. Tan and cot will be positive, rest negative. Cos and sec will be positive, rest negative, right? Precisely A, S, T, C. Right? How could you learn? You just make a sentence, a small sentence: all sugar, tea, coffee. All sugar, tea, coffee. All plus sine plus tan plus cos plus. If sine is positive, then cosec will be positive. If tan is positive, then cot will be positive. If cos is positive, then sec is positive. So all sugar, tea, coffee. Everything, all 6 trigonometric functions are positive over here. Only sine and cosec positive, tan and cot positive, cos and sec positive. So this is the first quadrant, second quadrant, third quadrant, and fourth quadrant, right? Now this is from 0 to 90, right? This is 0 to 90. That's 90 to 180. That is 180 to 270, and this is 270 to 360, right? Each quadrant is of 90 degree. Okay, so this is really important that you are going to use this here. Now, you know, theta and 90 minus theta are complementary angle. What are complementary angles? When the sum of the angles is 90 degree, then we call them complementary angles, right? So theta and 90 minus theta are complementary angles, obviously. Similarly, two angles are supplementary when their sum is 180 degree. So theta and 180 minus theta are supplementary angles. Okay, now this table you have learned last year only, last year also, and from all the angles 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. How do we make this table, and what are the values of sine, cos and tan over here, that you must be knowing, right? So I don't have to remind you once again. Now what this year we need to learn more values, right? We need to find out, right? How do we calculate a sine more than 90 degree? Suppose I ask you sine 135 degree, then what will be the value that we need to learn? Okay. Now one more thing over here, we have so many relations, right? Sine minus theta, 90 minus theta, 90 plus theta, and all that, right? This is the table over here, but you don't have to mug up this table. How do we find out the values of different trigonometric functions for different degree, that we will learn, right? We don't have to mug up the things, we need to learn them, how to find out. Okay, so let's move. Now you need to learn 4 formulae that I'm writing over here. Sine A plus minus B is equal to sine A cos B plus minus cos A sine B, right? Sine A plus B is sine A cos B plus cos A sine B. Sine A minus B is equal to sine A cos B minus cos A sine B, right? So if it is plus over here, it's plus over here. If it is minus over here, it will be minus over here. Similarly, cos A plus minus B is equal to. So we have cos A cos B minus plus sine A sine B, right? So cos A plus B will be cos A cos B minus sine A sine B. Cos A minus B will be cos A cos B plus sine A sine B, right? Using these 4 formulae, we'll be making so many other relations, right? So how do we make the relations? We just go one by one. First of all, we learn to find out the different angles, right? So I just draw the circle once again over here. See, on horizontal line, Sin theta is 0 and on vertical line cos theta is 0. So I write 0, 90, 180, 270 and 360, right? When the one full circle is completed, it's the measurement of 360 degree, right? One full circle. So it starts from 0 and ends by 360. Okay, now over here, as we have already discussed, all sugar, tea, coffee, all trigonometric functions will be positive in the first quadrant, right? Now we have to find out the value of sine a plus sine more than 90 degree, less than 90 degree, cos more than 90 degree, less than 90, tan more than 90, less than 90, right? So the first thing we take is sine 90 plus theta, right? So sine a plus b. Okay, sine a plus b, what will be the expansion? Sine a cos b plus minus cos a sine b. So sine 90 plus theta will be sine 90 cos theta plus cos 90 sine theta. So sine 90 is one that you already know. Cos theta as it is, then cos 90 is 0, and that's why this entire portion will be 0. So sine 90 plus theta is nothing but cos theta. Right. Now suppose you have to find out the value of say sine maybe 135 degree. So what you can write, sine 90 plus 45. Now sine 90 plus 45, that is precisely sine 135. Now sine 90 plus theta is what? Cos theta. So this is the theta over here, right? 90 plus theta. So sine 90 plus theta is cos theta. So sine 90 plus 45 will be cos 45. What is cos 45? 1 upon root 2. So what is the value of sine 135 degree? That is sine 90 plus 45. That is cos 45. That is 1 by root 2. So precisely sine 135 degree is 1 by root 2. So this is how you can calculate, right? Now this is sine 90 plus theta, that is sine 90 cos theta plus cos 90 sine theta, right? If it is sine 90 minus theta, still it will be cos theta because this portion is 0, right? So sine 90 cos theta minus cos 90 sine theta, but this portion is 0, so still will be getting cos theta. So sine 90 plus theta or sine 90 minus theta, both of them are cos theta. Okay. So here theta we are talking about greater than 0 and less than 90. You should be careful, right? Just do not take theta to be maybe 110 degree or something like that. Then this calculation will be wrong because in that case the quadrant will be changed. So here theta we are talking about just one quadrant, that is theta is between 0 to 90, right? So sine 90 plus minus theta. Now this is what? First quadrant, right? If it is sine 90 plus theta, that means we are talking about the second quadrant. If it is 90 minus theta, then we are talking about the first quadrant, right? So till here 90 plus theta and 90 minus theta, we have talked about two quadrants for sine theta, two quadrants for sine function. Okay, similarly we can calculate the value of cos 90 plus minus theta. So cos 90 plus minus theta. How do we calculate? Cos a plus minus b. So that is cos a cos b minus plus sin a sin b, right? So I just write cos 90 cos theta minus plus sin 90 sin theta, right? Cos 90 is 0, so we are will be getting minus plus sin theta. That means cos 90 plus theta is minus sin theta and cos 90 minus theta is plus sin theta. See, cos 90 plus theta, that means you are talking about the second quadrant, right? 90 plus theta, that means you are talking about the second quadrant, right? And second quadrant you are getting minus sin theta. That means precisely cos in second quadrant is negative, right? I already told you and I have proved it over here, right? So cos 90 plus theta, you are talking about the second quadrant. In second quadrant cos theta is negative. So cos 90 plus theta is precisely minus sin theta and cos 90 minus theta is plus sin theta because cos 90 minus theta, you are talking about the first quadrant, right? So the things become simple. Now similarly we can calculate 10 90 plus theta and 10 90 minus theta. So suppose we say 10 90 plus minus theta. So that is sine 90 plus minus theta upon cos 90 plus minus theta. So sine 90 plus minus theta is cos theta. If it is plus theta, then it will be plus theta. And okay, I take one at a time. 10 90 plus theta is sine 90 plus theta upon cos 90 plus theta. Now cos 90 plus theta that we have already seen, that's minus sine theta. Right? So 10 90 plus theta is minus cos theta by sine theta, or I can say cot theta. Precisely it is minus cot theta. Similarly, if we calculate 10 90 minus theta, then it will be sine 90 minus theta upon cos 90 minus theta. Sine 90 minus theta is sine theta, cos theta, and cos 90 minus theta is sine theta, so it is positive cot theta. Again, 10 90 minus theta, it is in first quadrant and we are getting the positive value, right? So you might have observed that all the 6 trigonometric functions, see if sine is positive, cosec is positive, cos is positive, sec is positive, and if tan is positive, cot is also positive. So using this relation, we have proved that all these 6 trigonometric functions are positive in first quadrant, and we have observed that in second quadrant sine is negative, sine is only positive. So if sine is positive, cosec will be positive, right? So we have talked about these 2 quadrants so far. Now we discuss about third quadrant and fourth quadrant. Okay, now on the same lines we can calculate sine 180 degree also, right? Sine 180 is sine 90 plus 90, right? Precisely this is the horizontal line. On horizontal line sine theta is 0, on vertical line cos theta is 0, right? So sine 180 will be 0. Okay, now what we do is we calculate sine 180 plus minus theta. Okay, and once again theta is between 0 to 90. So now we calculate sine 180 plus minus theta. So sine A plus minus B. So sine 180 cos theta plus minus cos 180 sine theta. Now sine 180 is 0 plus minus cos 180. Now cos 180, this line, right? So this is precisely origin x-axis and negative x-axis. So on this line cos 0 is 1, so cos 180 will be minus 1, right? So cos 180 is minus 1 and this is sine theta. Okay, so sine 180 plus theta is minus sine theta, and sine 180, I just write over here, minus sine theta, because we'll be using this plus minus sign, but it is minus over here, and sine 180 minus theta is equal to here it is minus and minus plus, so it is positive sine theta. Again you can verify sine 180 minus theta, that is actually second quadrant, right? So sine 180 minus theta and sine 90 plus theta, right? Both of them represent the second quadrant, right? So sine 90 plus theta, we observed that it was sine theta, and sine 180 minus theta, it is sine theta, right? In both the cases they are representing the second quadrant, so we are getting the same values. So you write sine 90 plus theta or you write sine 180 minus theta, that really doesn't matter. Okay, so sine 180 plus theta minus sine theta, sine 180 minus theta is positive sine theta. Similarly we can calculate cos 180 plus minus theta, right? So cos 180 plus minus theta, so it is cos 180 cos theta, sine will be reversed, minus plus sine 180 sine theta, right? Now cos 180 is minus 1 and this is cos theta. Okay, here it is 0 because sine 180 is 0. So cos 180 plus theta that is also minus cos theta, and cos 180 minus theta, that is also minus cos theta, right? So cos 180 plus minus theta is minus cos theta. Similarly, we can calculate tan 180 plus theta and tan 180 minus theta. So tan 180 plus theta will be minus sin theta by minus cos theta. So it will be positive tan theta, right? So tan 180 plus theta is positive tan theta. Then tan 180 minus theta. So sin 180 minus theta upon cos 180 minus theta. So still you'll be getting negative, right? So this is how you can calculate all the 6 trigonometric functions, right? So that's pretty simple. 180 minus theta, you are talking about the second quadrant. 180 plus theta, you are talking about the third quadrant, right? Similarly, we can calculate the fourth quadrant, the values in the fourth quadrant also, right? Here it is 270 degree plus minus theta. Okay, so let's do that. Now sin 90 is 1, that means sin 270 will be minus 1, and cos 90 will be 0, and cos 270 will also be 0. So now we calculate sin 270 plus minus theta, right? So that is sin 270 cos theta plus minus cos 270 sin theta. Sin 270 minus 1, so it is minus cos theta, right? Plus minus 0. So sin 270 plus theta, that is also minus cos theta, and sin 270 minus theta, that is also minus cos theta, right? So when we are talking about 270 plus theta, then we are talking about the fourth quadrant, and when we are talking sin 270 minus theta, that means we are talking about third quadrant. So sin 270 minus theta or sin 180 plus theta, both of them are same thing. 180 plus theta, that means you are moving this side, and 270 minus theta, you are moving this side, right? So both of them represent third quadrant. So sin 270 plus minus theta is minus cos theta. Similarly, we can calculate cos 270 plus minus theta. So it is cos 270 cos theta minus plus sin 270 sin theta. So this is 0, minus plus sin 270 is minus, and this is sin theta. So cos 270 plus theta, then we have minus minus plus sin theta, and cos 270 minus theta will be plus minus, that means it will be minus sin theta, right? So 270 plus theta, fourth quadrant, 270 minus theta, third quadrant, right? So cos 270 plus minus theta is cos 270 plus theta is minus sin theta, plus sin theta, and cos 270 minus theta is minus sin theta, right? So we talked about the four quadrant, okay? 0 to 90, 90 to 180, 180 to 270, 270 to 360, right? Now after one complete circle, the same story goes. The same story is there, right? 360 and 0. Same thing. So whether you write 360 plus theta or 360 minus theta, you are writing as 0 plus theta or 0 minus theta. Okay, so there is no difference at all. So we learned to calculate the different values of the 6 trigonometric functions, right? That is what happens between 0 to 180, 0 to 90, 90 to 180, 180 to 270, and 270 to 360. Now one more relation we have to see over here. Just a moment. That is sine minus theta. Now sine minus theta is precisely sine 0 minus theta, right? So sine A minus B, here it is sine A cos B minus cos A sine B, right? Sine 0 is 0, so this entire thing is 0. Cos 0 is 1, so it is minus sine theta. So sine minus theta is minus sine theta. So this is the line of 0. So if we are talking a sine minus theta, that means we are talking about fourth quadrant. So you write sine minus theta, or you write sine 0 minus theta, or you write sine 360 minus theta, same thing, right? Because we are talking about fourth quadrant. So in fourth quadrant, sine theta is negative. So sine minus theta, sine 0 minus theta, sine 360 minus theta is minus sine theta. Similarly, we can calculate cos minus theta. So that is cos 0 minus theta. So it is cos 0 cos theta plus sine 0 sine theta. So this portion is 0, so we can be getting cos theta, right? So cos minus theta is cos theta, sine minus theta is minus sine theta. Okay, so friends, in the next session we'll learn how to calculate the different values. Suppose if I ask you what is the value of sine maybe 1080, right? Sine 1080. So that how to calculate these sort of values, that we'll learn in the next lesson. So do revise this session. We'll learn the derivation of different formula, that like a relationship will be we'll see in the next session, right? So many formulae are there, so many relationships are there, that we'll be discussing in the next session. Okay, and this is really going to be an important lesson because weightage in your board exams is really high of trigonometric functions. Okay, so I'll see you in the next session once again. Do revise this session. Bye bye.